Wikipedia is a massive amount of information that can be used for natural language processing and machine learning. In this video, I'm going to introduce you to a short utility that I wrote that I use to traverse across the Wikipedia dump files and extract the information that I need. I'm going to show you how to get access to articles, templates, links between the articles, and all this kind of stuff. This is all using a simple utility that you can run on a single computer. The more cores that you have on the computer, the better, because it's going to parallelize across the files. I'll also show you how to download all of the Wikipedia data in several BZ2 files and keep it into BZ2 format on your disk so it doesn't take a crazy amount of space and traverse across those. So we'll begin by going to my GitHub repository, which is here. And then all my YouTube stuff is under present, unless it's big enough that I've given it its own repository, but it's under YouTube and then Wikipedia process. So here you'll want to download these. I've already got them downloaded and you can see them here in VS Code. What you're going to want to do is first download Wikipedia. So here we have the example download path. You're going to have to put the path that you want to actually store it at. Here is where I'm storing it. As we start to move things in from the Wikipedia downloads, you'll see files appear there. We'll run this. I will go ahead and run this right in the terminal in VS Code. You don't have to use VS Code. I'm basically just running Python. Okay, it's running. You'll see it says it's missing the BZ2 file. It goes through and it checks each of them. If they're already there, it's not going to download them. And if it also checks the SHA hash to make sure that they're not corrupt. So notice it's downloading basically the April 1st, the April Fool's Day edition of Wikipedia. It's actually not April Fool's Day, but you'll see it start to download here. You can see it's created a DL directory, and inside of there is the date of the copy that you're grabbing. And inside of there, you'll see the BZ file. Now, we're going to leave these as BZ files. I'll just have Python open them up, compressed, and run over them. Now, this part is going to take a while because we're downloading Wikipedia, which is very, very big, even compressed. So let me go ahead and just fast forward through this. So yeah, this is still going. This definitely takes a while. And I have this on a Wi-Fi connection, so this is not even the fastest connection that I have available to download this. I might modify this in the future too to use threading to have more than one of these files being downloaded simultaneously. Right now it's just in a loop. So we'll continue with the fast forward. All right, that took a while. Now this will be entirely determined by your internet speed, and I don't have a particularly fast internet connection. I don't really need one for what I do. So let's see all these files. You can see we're up to 27. You notice there's duplicates sort of each. They have different page numbers, and those show you basically the page ranges on these. I think that's what those file names actually indicate. Not entirely sure, doesn't really matter for what we're doing. Basically, what this gives you is all of these BZ2 files. Let's see how big it is all together. 33 gigabytes compressed. So yeah, that's a lot of data. But on modern computers, I mean, the computer that I'm running here has 128 gigabytes of RAM, so I can easily fit this into RAM if I so desired. But not sure how big it is uncompressed. I usually don't deal with it uncompressed. Let's go ahead and look at how we actually process now Wikipedia data. You'll see there's several examples. There's the example of how to download. That's what we just did. There's also process Wikipedia. This is the main sort of a library that I'm putting together. I'll probably eventually make this pip installable. But this is the beginnings of a library that I'm putting together that has what I need to deal with Wikipedia dumps, to use machines that have a lot of processor cores to go across them, or even 4 processor cores. Like I also run this on my MacBook, which is just a quad core with 8 virtual total cores. So here, just looking at this, I give a class wiki dump and download wiki file. This is what we just did. This is meant to be really very resilient because you're downloading this big thing. I mean, this has been running most of the day on this. But if something might have happened, if one file would have failed, it would have just stopped, gone on to the next file. I can rerun the example download, and I'm going to do that right now, just so you can see really what happens. It says exists, and the reason there's a pause on each of these is it's actually running the SHA hash against those just to make sure that they are the files that we expect them to be. And a few things that I have defined up here, I am using the Wikipedia English. You might want to use a different one. Some of the parameters you may want to adjust. You can also pass in something other than English because that's just what I use as the default. Then you'll also see there are extract wiki file. This is basically what is ran on each of your cores. This takes the Wikipedia XML and breaks it apart by pages and then sends each page off to your individual workers, which are controlled by, well, these are the individual workers. And then the workers, so that's sort of like the map step, sends them back to this extract Wikipedia, which is then going to call your code to actually aggregate them all together. So that's sort of the reduce step. So let's look at just a very, very basic example. I really mean that you should not have to modify process Wikipedia. I'm going to work on that even further to make it truly a reusable library and give it some additional capabilities. I'm trying to make it very robust because you're running this on large amounts of data and you may need to potentially start and restop it. It's not as advanced as I want it to be, but this is something that I use enough, so I'm giving you kind of my code to help you be able to build your own. I would recommend using Example Basic if you just want to start out and create your own Wikipedia data extraction. You want to just go across Wikipedia, do something, maybe get the population of all world current countries or something like that. I give you 2 classes because for something like what we're doing with Wikipedia, this really has to be almost a MapReduce sort of concept, meaning the process worker, this is really sort of your map step, but not exactly. This is what is, you're creating this class, giving it as basically a callback to my code. And what it's going to do is call your process template for every template that it finds in Wikipedia, your process article for every article that it finds, redirect for all the redirects that it found, and it's also going to report its progress to you just so that it can output and tell you what's going on. So this part, you would want to do all your heavy lifting here because this is what's going to be split across all of the cores of your computer. And this works okay with a quad core, a dual core machine. This machine I'm running on is 24 physical cores, 48 virtual, and there's a lot more powerful machines than this. This is an AMD Threadripper. The higher end Threadrippers have considerably more. This is about $1,000 CPU that I'm running on this computer, US dollars. Process pages, this is going to be your aggregator. So up here, you'll notice I'm calling the output queue on these and sending the data as this part of it extracts that and returns it back. Down here, all I'm doing is putting links, basically a row in for each article I find, a row in for each redirect, a row in for each template. And this just builds 3 CSV files. This is really your most basic example of traversing across Wikipedia and getting all of this. Handle event, if it's an article, if it's a template, and that's defined by up here. Those are the maps that you're sending. You can add your own types of instructions that are going across. The thing I'll warn you, though, on performance, especially if you see your CPU performance not pegging the upper 80s, 100%, you're probably sending these across in too small of packets. You're just pinging the heck out of the pipe. You need to try to batch those up a bit more, and I'll show you in a moment how I do that on a more complicated example. And then this is just going to write out each of those. And at the end, when you call close, it's going to close those 3 files. So this is very much how I extract Wikipedia data. This first part in a Python program, this is just the first part of a pipeline. I try to get the data out, and then I'm going to put it in these CSV files, and then from those CSV files, I'm going to run something like a blazing SQL, which I'm going to get to in next video, and show you how I'm going to then take those raw CSV files, tabular data, and get it really into the form that I want to, because I'll have to do, we'll see what I have to do there in a moment. But the idea in this first phase is just get the data structurized, get it into a CSV, and then we'll go from there. At least this is how I do it. If you've got other techniques, definitely let me know in the comments. So let's look at the slightly more advanced example. Now this is a data set that I'm building from Wikipedia. And again, you'll want to set your root wherever that is going to be. I'm going to actually run this one. So I am going to go ahead and modify the Wikipedia root. I'm going to copy it just from the basic example that I already had set up. Actually, from the download example that I already had set up. I run these on Windows, Linux, and Mac frequently. That's why you have those comments up there. That's how I test it. I probably should have my testing a little more automated, but if I make this a formal library, I will certainly do that. What this is going to do is we're going to build 5 CSVs. And while I'm explaining it, let me go ahead and kick this thing off so that it's actually running. So I'm just going to do Python example cats and links.py, and I'll run it. You'll see it's using all 48 cores on my computer, and it's going through all of these. You'll see how many files it has, and it's running parallelized. So it should be, I don't have this completely optimized as much as I would like to have, and I've optimized it mostly on the Linux side, but not too bad. I would think, I don't think this should be IO bound. So it's at about 66% CPU. There's definitely some more optimization that I could do on this. And this is zipping right along. This is actually pretty good performance that it's, decent. It's already up to 3,000 or 3 million. So I'm going to create these files. Article CSV is just going to be the ID and title name of each of the Wikipedia articles that it discovers. Article template, that is going to be the article ID and also what templates it has. This will be a one-to-many because an article can be in many different templates. Those templates are really useful to me. That's how I know what type of an article it is. Not perfectly, but again, Wikipedia data is not perfect. It's a bunch of humans running around and tagging things. Article link, this is going to contain a link between the articles. And this is something I have to clean up later in blazing SQL or pandas if you have enough memory. Article link is basically keeping track of all those links between Wikipedia articles. So this is a massive many-to-many table. And I am going to store in it the article ID from the source because I know the article ID that I'm currently on, but what I don't know is the ID of the target article. I haven't completely traversed Wikipedia yet at this point when these are coming in. So for these CSV files, I actually write out the title of the target with the ID of the source. I want to get that ID to ID, and that's part of what I'll do with a large join in something like a blazing SQL. But we'll get to that later, in a future video, actually. These are all the redirects. Redirects are useful, like I think United States, the key article is United States in Wikipedia, but then they have redirects from USA and United States of America and anything else this country might be called. So that the redirects are very useful also in natural language process because they let you know n-grams, so multi-word pieces of information synonym type relationships. So you know that USA and United States of America are basically the same thing. There's also disambiguation pages, which can be useful for other things. This is just a list of all of the templates and the template and the article ID. So I'm trying to build up all of these files basically. And this is just the code to go ahead and open them. I use the Python CSV. Now it's very important. I am using the CSV writer. I'm not using Pandas or something like that. I want to stream. If I don't stream, I risk running out of memory. Now, this computer has a lot of memory, but I don't necessarily want to use memory, basically be lazy, because this is really something you should stream. That way you can generate as big of files really as you need. I like that most code that I release on this channel to have a maximum of about 8 GB RAM requirement, if even that. Basically, if it can run in Colab. Now, running this in Colab, probably not that good of an idea because you're going to have this I/O issue of how do you get access to Wikipedia in your Colab. You're going to have to like download it each time. I don't know how fast it would be if you mounted it on a G drive. I have not tried that. That might be something for a future video. If you're interested in mining Wikipedia with Colab, let me know. Now you're going to only have 2 cores, so this part's going to be kind of slow. And then here we have basically the headers for each of these. On the article to template, it's article ID to template name, because I don't know the ID for the template. I just know it's text name. So this is going to be a big join, and there can be errors. People can mistype. Wikipedia editors can mistype template names. I've seen that happen many times. So there's some cleanup that needs to occur, and that'll all be done in Blazing SQL in a future video. And likewise on the links, we're connecting our article IDs to the actual template name. I will resolve those to actual IDs in a second step down further in the pipeline, either using Pandas on a large RAM computer or Dask perhaps. The video I will specifically create will be Blazing SQL. Here is where we're writing all of these. And this is a very important performance step here that you'll see. I am writing, notice I use write row on some, write rows on some of the others. I probably should take some more time and get article to be a write rows instead of row. That might be some of the reason that we're not seeing the CPU pegged at 100%. And I will tell you, the more cores that you have, keeping a Threadripper with 48 CPU cores busy is difficult. It really shows you how performant you've written your code for parallelization. And there's definitely some more improvement that I want to do on this. But what I'm doing here is for the links, I don't want to just call the pipe every time I find a link. That pipe is going to be a fire hose. So what I'm doing is on the individual workers, the things that are running on each of the core, I'm buffering up those links and sending them once per page. Might even be useful to buffer them up a bit on articles because there's a lot of articles in Wikipedia. That 21 million count that you see down there, that is literally how many there are. And again, this is Python, so this is the global instruction lock. So I am using multiple processes to keep that running. I don't know if Windows actually shows that or not. Yeah, it does. So here are all of my, it doesn't show it as nice as I would like to see it, but those are all my well, not threads, but processes. Processes pretending to be threads. And I'm basically just sending one file to each of these. And by the way, also, when I get close to the end of this, the CPU will drop off more and more because I'm basically sending each of those files, those 60 files that we have, to individual processor cores. And once we start to get done and there's not new files for the processor cores to work on after they're done with their first one, we just eventually wait until all the files are processed. So the very, very final file, there'll be just one processor core working on it at that time. And then up here, so that's the aggregator, the cats and links pages. The individual workers, this is pretty similar to the basic example. This is the cats and links worker. Every time I get a template, I'm just passing it on to the template writer, just like the simple example. Process and article gets a little more complicated. This line is doing the same thing. I'm writing out to the CSV the ID and the title, but now I'm parsing that Wikipedia page, and I'm using page.wtp. Now there's several of these. I prefer Wiki Text Parser. There's something called like Blazing Fireball or something. I forget what it's called. But there's a number of these, and I probably will do some performance benchmarks on these just to really see which one I might want to support longer term. But this is not used in my core process Wikipedia because it's just passing the text back to you. You need to actually parse it yourself sometime. And if you're doing something simple, you might just want to go after it with regexes. If you go to Wikipedia itself, and if you look up, I don't know, Wikipedia, in Wikipedia, kind of a recursive loop, you'll see there's like an info box there. Those are how I sometimes know how to categorize these. So you'll see up here, info box. I use these a lot. It's a website. So you could search for all the websites that are important enough that they have Wikipedia articles for them just by using these info boxes. That's why I'm building up a CSV that has all of these templates, which are these double open curly brace that Wikitext Parser is finding for me. So I basically parse the page and I loop through it, and I one by one get the name of each template. I do set up a little bit of a set here just so that I can filter out duplicates. Otherwise, there's a lot of duplicates. Because some of these, like the citations, they're really not duplicates, but at the level that I'm looking at it here, they are, because I'm not looking at what it was a citation to. So you might want to grab out some more of this information, and you would just modify the code here to do it. So then I write the templates out, and I do almost the same thing to loop across all of the links. And then that gives me all of the links that I would need. Now you can see this thing is still zipping along here. I am going to let this run, and we'll fast forward this. This doesn't take nearly as long as the previous step, I hope anyway. It's 12 of 60 files, so it's more or less a fourth done. So let's go ahead and fast forward this. All right, that is done. So let's take a look at the output from that. These are the files that were generated. So if we I'll look at these in Excel. It'll only be able to show the first part of this. File not loaded completely. But here you'll see the article IDs from Wikipedia. These are actually Wikipedia generated IDs. You can see some of these have fairly low numbers, some have higher numbers. No idea how those are generated. Let's look at something, and you can see some of the sizes here. This is 8 gig, 1.2 gig, the article link and the article template. Thank you for watching this video. In the next one, we're going to look at how to do something with these CSV files that we got. We're going to use Blazing SQL, bring them together into a concise database that I can use to look at links between articles in Wikipedia. Please subscribe to the channel so that you don't miss it. Thank you for watching.